Okay, so today we are going to discuss about the network types. Okay, and yeah, hope so. Hope everyone is clear about yesterday's class. I'll discuss about that later. So first, I'll go through this. Okay, so today we are discussing about the network types. So first, uh, so what is network? So can anyone tell me what is mean by network? Okay, so usually you should answer. At least you should talk. You should talk. Maybe it will make some interesting. It's always like a one-way traffic. So, so what is mean by network? So I'm just asking generally. So what is mean by network?
A set of computers,
Yeah, set of computers.
like connecting every device
Yeah,
on
yeah,
network, like a tree.
yeah. So like it's like interacting with each other, right? So that means a network, basically. So like if you and me are talking, so it's a network and we are talking each other. So same way. So we have a network. Okay, you have the network, but you need to know how to implement your network also. Like what kind of technologies we are available, we have in the network. Okay. So I think everyone knows about the LAN, the first one we are talking. Okay. And the second one is WAN. Third one is PAN. And these are all the general things you will see regularly, but yeah, we don't like yeah, we don't know the names. That's it. So and there are a lot of actually, but if you see, yeah, there is a VPN, so that is also a kind of network. Okay, so these are the main things. So first we'll go one by one. Just take one as example, like this. So first take LAN. So what is mean by LAN? So LAN is local area network. Okay, local area network. So for example, let me draw a diagram here. So let's take, so this is your office. Okay, and you have 10 systems. I'm just taking it as example. Okay. So you're using a hub or a switch in between them. Okay. Okay. Just forget about the diagram. So so local area network. So this is the most common type of the network. So basically, it is like in a small geographical area. If I say in a small geographical area, so this is a small geographical area. If you take any office, that is a small geographical area. So how big is the organization? That is within the building, right? It is not between the different buildings. It is within the building or within the city. So it is like that. So in your house, you have a Wi-Fi router, and if you connect a LAN cable to that router, and you connect it to your laptop, and same way you have one more port and you will connect it to the another network. So that is a LAN. So within a small geographical area, if you connect users, or means if you connect devices in network, that is called a local area network. So within a small geographical area. Okay, so usually you will see this kind of thing in everywhere. Like, so take any office, so you have Wi-Fi option and you have LAN option. Okay, so yeah, and I can say there is some reliability in the LAN connection. Like if you connect to the Wi-Fi, so it is tra the signal will travel over the internet. Like you will get the signal over the air, and there might be some disturbance or something like that, right? So we may see some disruptions, but coming through the cable, it is very standard, and we can expect fixed speed also. Okay, so you will see land everywhere. Without land, there is no office and there is no network actually. So without cable connectivity, there is no network. Okay, so we that is our like a day-to-day part, regular part. For example, if I say, uh, so usually, generally, I'm just telling you one thing. So you have one user, so he is connected here, and you have one more user, and you have one more user, and you have one more user. Okay, so you want to do a file share between all of them. Okay, you want to do a file share. So what is mean by file share now? So file share means, so there is a some file in this user PC. Okay, this is the first user. So there is a file, we want to access it by everyone. Like, actually, I want to access that file. Like I am here, and you want to access it. Maybe you are here. So we cannot go into his PC and manually, and we cannot logging into him, and we cannot do it, right. So what we will do is we will do a file share option, but that can be done whether if you are in a network. So You can do it in on any network, but I'm saying it as an example, like if you are connected in a same LAN, so yeah, we can do it. Okay. So within a geographical area or within a office or within a any organization, if I say if you connect your devices, so that is a local area network. So we will call it as a local area network. And so the next one is uh, WAN. So wide area network. You know, everyone is using this Wi-Fi, right, nowadays. So without Wi-Fi, there is nothing, and we don't have internet also. Okay. So in the name itself, it is saying like it's a wide area network. So what is mean by wide area? So it's yeah, you can connect everywhere in the globally by using the WAN actually. Okay. So the WAN is the main reason for us to connect to the internet, and by using the WAN connection only we can go to the internet. Okay. So in an organization, the connection looks like this. Uh, okay. So you guys are the users. So here, and you will be connected to a switch. Okay, so this is a switch, and all of them above we have a router. So okay, these are the four devices connected, and yeah, we have the connectivity between router and switch also. We say this is the router. uh, this is the switch. Okay, and you want to access internet, which is here. So here, so this is part of LAN, local area network. Okay, so just so in the local area network within a small region, but the internet is outside your organization and it is publicly accessible. So you want to go from this PC, like this PC one to google.com. Okay, so the internet. So the path should be, so first you will reach out your switch, and as I told yesterday, whenever you give IP config, you will see a gateway. So the gateway IP is your router IP. Okay, so basically we will have a ISP connection here, like I say your ISP is suppose Airtel. So you will have the connectivity from Airtel to your router. Okay, so this is our ISP. ISP means Internet Service Provider. So he will provide us the internet services. So whenever we have a request, so we will go to the router, and then it will forward it to the ISP. And then from that ISP, I can reach out to the Google, or I can reach out to the Facebook, I can reach out to any public website. Okay. And I can reach out to the server which is in America, the server which is in any location in the earth. So that is the wide area network. Like in a wide area network, you can connect to a larger geographical area, and it is an internet service. So that is the one we referred as a wide area network. Okay. Uh, so hope everyone understand it. And the next one is the PAN. So personal area network. Uh, okay, simple. If you use your hotspot, so your phone has an hotspot and you will turn it on and you will connect to your laptop, right? So that's a personal area network. So no one can access it except you because you are the owner of that network and you can protect it by a password. So that's a small thing. If you use it between a one person or like that, we will call it as a personal area network. So that is a PAN. Okay. And the next one is MAN, Metropolitan Area Network. So MAN network is like so so if I take, so it is the connectivity between metropolitan cities. Okay, so we have an office in Hyderabad and we have another office in Bangalore. Okay, so this is our Bangalore office. So this is our Bangalore office. Okay, so we have one in Hyderabad. So this is the Hyderabad office. So we want to establish connectivity between these two over LAN. Okay, not over the internet, because if you go over the internet, it is publicly accessible. Maybe anyone can try to hack into this network and they can make some disruptions in our network. So usually they won't prefer and they will prefer as a like this uh, LAN connectivity. So how we can establish? So simple. So we have Airtel here, and in Bangalore also they will have a Airtel. Okay. So we will request them like we need a specified network for us. So what they will do like, so there definitely there should be connectivity between Airtel in Hyderabad to Airtel in Bangalore. So what they will do, they will assign a space. So we will call it as a P2P link or MPLS link, so that we can establish a connection between these two branches. And one more thing, suppose you have Airtel and you don't have it in Bangalore, maybe if it is a different vendor also, if the same vendor is available in Hyderabad, so we can extend our connection to Geo from Airtel to here. Like you will not change your ISP, you will just extend your connectivity to Geo, and from Geo to Geo they will establish the connection. Okay, so just it's a connectivity between the different cities, and you will use your service provider for that connectivity. Okay, that's a metropolitan area network. So just in the name itself, you can define that it's a connectivity between multiple larger cities like that. Okay, and one more thing is the next one is storage area network. So like if you see in a organization example, uh, I can't tell you the outside situation, but if we are in an organization, so what they will do is like whenever they have something like if any customer for any customer they will create the multiple networks. Okay, suppose they'll create this so they'll create the multiple networks like if I say my internal and external and DMZ. So internal means the subnets which are internally, like I said, like LAN. External means so the subnets which can be accessed exposed to the internet. So external or DMZ is same. And one more is we will dedicatedly create a storage network actually. So like there is no traffic on that network except your backup, right? Every day we will take the backup of servers. Okay, so we will create a dedicated network for that. And we will assign the IPs, like we will assign IPs to these servers and they will flow through that dedicated network actually, because in the backup each and every day, so there are some scheduled backups if I say. So you have some 1 TB of data in this entire ESXi server. So this is your server. So you have 1 TB data and you want to transfer it to your backup server. So maybe that is here. Um, that is here. So in that case, if you do it on your general network, so it may interrupt us the existing connections, right? Like suppose you are using internet and the same way you are using this storage backup network. So what will happen? It will create a load on your current network, and so due to the high traffic, we might experience the latency issues. So that's why we will create a dedicated storage network actually. Okay, and yeah, so usually you will create a dedicated storage and area network, and you will transfer all your backups instead of using your local LAN, WAN, or PAN or MAN, because so the rest of the traffic is users traffic. Like our users will try to access file shares, and users will try to access this internet. So there might be a lot of traffic, right? So that's why no one will prefer that dedicatedly in most of the big scale organizations. Dedicatedly they will create a storage area network, and they will just simply it's a backup network, if I say. So every day the backups will go via this. Okay, so you guys understand about LAN, WAN, PAN, MANs, and just let me know if anything we'll discuss. So So what is LAN? So if you can, it can be used in a small geographical area, if I say, within an organization. Okay. And coming to the WAN, it is over the internet. Like you can take multiple regions like Asia and Europe. So if you want to connect between multiple regions, we need to have the internet connection. And for that, the best way is WAN. Okay. And the next one is PAN, personal area network. Like you can say your own Wi-Fi or your own hotspot. So, or yeah, you will use the mobiles, right? Like there is a hotspot option, or there is an airdrop option in iPhone. So these are our personal networks. Okay, no one can enter into that. So that is a personal area network. So metropolitan area network means so so there are multiple branches in your organization, and you want to establish the connectivity in a secure way. Okay, so definitely you will have by over internet, but if you want it in a secure way, so there might be a way, right? So that is the MAN network. Like we will lay the cable between both the um, like both the branches. Okay, so we will not do it. There might be some vendors. I will show you how it will happen. For example, if you want to, you have an office, like generally, the recent scenario, I just recently worked on it. Like, so there is a customer which is in North America region, okay, North America, and we have a data center in MI1, like Michigan, okay. So we want to have a direct connect between these two, okay, but we cannot lay the cable between here to here, right? I hope you will see there is a vendor called Switch actually. So what he will do, he is the switch. So he is the guy. What he will do is like he will be a like he will be the mediator between these two branches. So he will connect a cable with this switch in the North America region, and in the Michigan region they will connect a cable to our DC also. Okay, so that we don't have the cable directly, but we have an intermittent device which is called a switch. It is a dedicated company that provides these kind of services. Okay, yes, just please respond. At least say okay. or something like that. I'm getting bored actually. Just let me know if you have any problem, yeah. We can stop there and we can discuss that thing.
And this example is for,
This example is for MAN, Metropolitan Area Network.
okay,
So
connection
you,
major
sorry,
cities.
huh?
Connection between two major cities, right?
Yeah, two metro cities. So usually we cannot lay the cable right between two different cities. So we will use a in between vendor. Okay.
Okay.
So
It's just like
you,
fabric
for
for,
example, Airtel will be there in the Hyderabad and Bangalore, and they have fiber cables. Okay. So what they will do, like if you ask them, like we need some LAN connectivity, they will create a dedicated line for you. Like this is the same line, this is the physical line, but we can divide this line into logically into multiple things. So we will divide that and we will give some space to you so that you can securely connect. Okay, that's how it will work. And so you are clear about LAN, WAN, personal area network, metropolitan area network.
yes.
Okay.
Yeah, when
So the next one is SAN, storage area network. So this is your organization and you are using this traffic. Suppose this is between your branches and you have a backup server here and regularly you want to end of the day. Like once your day completed every day, early morning, 2 a.m. or 3 a.m., you want to send the backups to here. Okay. And so in that case, if you use your regular network, it may cause some issues, right? So what we will do is like connecting all this, we will create a backup network, dedicated backup network. Okay. So all your backup traffic, like the storage, okay, the backup traffic will come via this dedicated network and it will be stored into this device, whatever it is. Okay, but if in the same way, if you use the your regular network here, so it may cause some interruptions. Okay, like because why I'm saying is backup is very large amount of data transfer. It's not like so in our PC maybe it's 500 GB or 1 TB, but if you take nowadays it's in terabytes. So maybe 100 terabytes, 200. Yeah, one day I can't even I don't know exact number. So it depends on the organizations. But every day they will take backup of everything because we need to provide the redundancy to our customers. So redundancy means if something goes wrong with the production one, like you have two servers, so this is one and this is another one, and what I will do is like I will keep a copy of this one and I'll keep a copy of this one. If suppose anything goes wrong with this server and this is corrupted, so in that case, what we will do is we'll just create a new one. We'll just bring up the backup to here and we'll make it work. Uh, Okay, so that is how it will work. And the storage area network is a larger one. Like it handles a lot of traffic. Okay. And the next one is the VPN. I know everyone using the VPN like virtual private network. So if I say simply, you want to connect to a server. You know WAN, right? You are here, and you want to connect a server which is in internet. Okay, this is the user. So this is your internet. Okay, so you want to access something over the internet. So but there is no security in the internet, right? So maybe someone will come and they may see your data. So in that cases, what we will do is like we will create a secure tunnel between user and internet. Okay, user and internet, or it's not only internet. Yeah, you can think like other branch also. Okay, not only internet. So what we will do is like we will create a tunnel here. Like we will create a secure tunnel here between you and internet, so where no one can enter into this, like, into that network. And now your data will be, whenever you go here, it will be encrypted over the internet while it passing through this tunnel, and once it reaches the destination only, it will be decrypted. So you know what is meant by encrypted and decryption, right? Encryption means your data will be transferred into this like, if I say yeah, ASCII mode or any binary data. Suppose if you are sending a hello message, yeah, hello, maybe it will be transferred to, yeah, maybe it will transfer like this, like, yeah, this is. So will you understand it if I send it like this? No, right? So the data, when it is sending over the internet or when sending it is through the tunnel, so the complete data will be encrypted. Okay, so no one can access that, or no one can hack into your network. So this is the VPN, and we'll create a secure tunnel between you and the destination, or between your two branches, or between you and internet. So no one can see your data or what you are doing, and yeah, and we can create a secure way, and while whenever you are entering the tunnel, your data will be encrypted, and once it reaches the destination, it will decrypt the data. Like while going through the tunnel, it will send this message as this one, and once it reaches the destination, it will mark it as hello, because this customer, like if it is a user, he needs to understand, right? So that's how. It's a VPN is a private network we will create dedicatedly between multiple vendors or multiple branches or multiple organizations, or between you and the internet. So it's a regular thing we are using in nowadays. Okay, it's a private network, so no one can enter into that network actually. It's a virtual private, and we have a secure tunnel created here. So the data will be encrypted and decrypted in that VPN network. Okay.
Sir,
Yeah.
difference between VPN, WAN రెండు
So
ఒక దగ్గర
WAN
నుంచే
మామూలుగా,
వేరే విషయానికి యాక్సెస్ చేస్తాము.
సో వ్యాన్ ఏంటిదంటే నార్మల్ ఓపెన్ ఇంటర్నెట్, లైక్ నార్మల్గా మనం గూగుల్ యాక్సెస్ చేస్తాం కదా.
ఓకే.
సో అది వ్యాన్. బట్ విపిఎన్ ఏంటంటే లైక్ యూ విల్ బి
ప్రైవేట్ అంటే
గోయింగ్ త్రూ ఏ సెక్యూర్ ఒక సెక్యూర్ కేబుల్ అన్నట్టు. ఇఫ్ ఎగ్జాక్ట్లీ. సో బిట్వీన్ యూ అండ్ ఇంటర్నెట్ ఇక్కడ ఏంటంటే మనం ఒక సెక్యూర్ టన్నల్ క్రియేట్ చేస్తాం. ఓకే. సో
ఓకే.
నార్మల్గా ఫర్ ఎగ్జాంపుల్ ఇప్పుడు నువ్వు ఓపెన్ ఇంటర్నెట్ వెళ్తున్నావు, లైక్ యూజింగ్ యువర్ ఐఎస్పి. ఓకే.
ఓకే.
ఎవరు? ఎయిర్టెల్. సో నువ్వు ఒక్కరే కాదు ఎయిర్టెల్ యూజ్ చేసేది, మేబీ నేను యూజ్ చేస్తా, ఇంకొక పర్సన్, సో మల్టిపుల్ మెంబర్స్ ఉంటారు. అండ్ సమ్
ఓకే.
ఇక్కడ ఏంటంటే అది ఓపెన్
సెక్యూరిటీ
కావాలి.
ఉన్న స్టోర్కి వెళ్ళడం మీరు.
సారీ,
ఓకే. ఓకే, చెప్పండి సార్. ఓకే.
నార్మల్గా సో ఇంతమంది యాక్సెస్ చేసినప్పుడు ఇట్ ఈస్ ఈజీ టు హ్యాక్, రైట్? ఓపెన్ వెళ్తున్నావు నువ్వు, సో దెర్ ఇస్ ఎ ఛాన్స్ టు హ్యాక్. సో అందుకే వీల్ క్రియేటెడ్ సెక్యూర్ వే, లైక్ ఒక టన్నల్ క్రియేట్ చేసాం మనం. లైక్ ఇఫ్ ఐ సే ఆల్రెడీ ఉన్న నీ ఎగ్జిస్టింగ్ లింక్ ని నువ్వు ఒక సెక్యూర్ గా క్రియేట్ చేసుకుంటావు. ఆల్రెడీ నీకు ఇట్లా ఒక లింక్ ఉంది, బట్ దీన్ని ఏం చేస్తావు అంటే బిట్వీన్ యూ అండ్ ఇంటర్నెట్ మనం ఒక సెక్యూర్ గా ఒక టన్నల్ క్రియేట్ చేసుకుంటాం. లైక్ మీకు క్రియేట్ చేస్తే అర్థమవుతుంది, బట్ ఐ టెల్ యూ ఇన్ ఫ్యూచర్. సో ఈ టన్నల్ నుండి వెళ్ళినప్పుడు ఏమవుతుంది, డేటా అంతా ఎన్క్రిప్టెడ్ ఫార్మాట్ లో ఉంటుంది. అండ్ నీ ఐపీస్ అన్ని హైడ్ అయిపోతాయి. నో వన్ కెన్ ఎక్స్పోజ్ ఇన్ టు యువర్ ఐపీస్. సో ఇట్స్ వెరీ హార్డ్ టు హ్యాక్. ఓకే, సో దట్స్ వై దిస్ ఇస్ డెడికేటెడ్ నెట్వర్క్. అండ్ ఎవరికి ఈ నెట్వర్క్ గురించి ఐడియా కూడా ఉండదు అంటే అవుట్ సైడ్. సో ఈ టన్నల్ నెట్వర్క్ అనేది నీకే తెలుస్తుంది, లైక్ ఓన్లీ లోకల్లీ ప్రైవేట్ నెట్వర్క్ టైప్. నార్మల్గా మనం విపిఎన్ సర్వీసెస్ తీసుకుంటారు కదా, సో వెన్ యూ యూజ్ దాట్ ఇట్ విల్ హైడ్ యువర్ ఒరిజినల్ ఐడెంటిటీ and it will expose with a different identity. Okay, but I told you yesterday, even though if you are hiding your IP, MAC will be there, so they can trace us by the MAC address. Clear?
వినోద్ హలో.
అండర్స్టాండ్ చేసుకున్నావా? మరి అర్థమైందా?
ఓకే బ్రో, గుడ్. లాస్ట్ నాకు ఒకసారి డిస్కనెక్ట్ అయింది వైఫై అవడం వల్ల. ఇప్పుడు ఏమని చెప్పారు సార్ మళ్ళీ లాస్ట్ 1 minute?
ఏం లేదు, నార్మల్ అదే రిపీట్
ఓకే
చేస్తాం.
ఓకే 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 అర్థమైంది.
ఓకే, వేర్ గుడ్. నెక్స్ట్ వెళ్ళొచ్చా?
వినోద్ హలో.
యా హలో.
Yeah, in WAN also we connect 2 branches or multiple branches, right? So
Yeah.
when to WAN, coming to this VPN network, the encryption comes under only in VPN only.
Yeah. So it's a private network we are creating, right? And we are using certain encryption mechanisms under that. Okay. WAN అనేది just internet నీకు open గా, so it's publicly accessible, like anyone can access Google from anywhere if they have internet connectivity. But so if you want to access the Google in a secure way, so there might be a dedicated network for that, right? So that
Yeah.
is the VPN network.
Yeah, Vinod, got it.
Yeah. Okay. Now, so basically in network, so there is a way like how this connection should work. So like ఇప్పుడు let me take the screenshot. Okay, so now coming to the standard procedure of the OSA model. So what is meant by OSA first? Ever heard about this?
No.
Okay, so OSI means the first thing is it is an open internet connection actually. So why we need this open internet connection means OSI, open system internet connection. Sorry, open system interconnection. Okay, so why they introduce this OSI model is like, you know, we have multiple laptops, multiple vendors, right? We have a Dell laptop, we have a Lenovo laptop, we have some HP laptop. So earlier, if you see, everyone is using a dedicated switch. Even if you consider your mobile also, everyone is using their dedicated port type charging pin, if you see. But now we have a standard C cable, right, for each and every phone. And in the same way, for laptops also, if you see, nowadays we are getting a USB charger. Okay, for all the vendors, but it is not like that in the beginning. Like everyone is having their own dedicated standard port, and suppose if anything goes wrong, user needs to go to that vendor only, and he needs to replace it that specific port. Okay, so that is happening with each and every vendor. So there is an organization like organization ISO. If I say for each and every organization, there is a like for cricket we have ICC. Okay, like for each country they have their dedicated board, and but ICC is the main board, like who can design the rules, right? In the same way, you have International Organization for Standardization, ISO. Okay, that is the organization who can fix some standard rules. Okay, like suppose if you are using your own product, using your own things, and if I want to connect between Lenovo and Dell laptop, we are facing some difficulty. Okay, so if I want to connect between these two laptops and you are using your own standards, so you are Dell here. Just let me know if you are not understanding, because this is a basic and important topic. If you don't understand this, yeah, we need to. This is the OSM model. It will stay with you until unless, like every day in your regular work day, like in your work day, you have to deal with this model. So you will not study physically, but everything you will do from this model only. Okay. Just let me know if you don't understand anything. So this guy is Dell, and he is a he is a Lenovo. Okay. So he is asking like I'm creating my system with my own interest and my own standards. Okay, and you are creating your system with your own standard. Okay. If you want to connect with me, maybe you need to buy a device from my end, like not an entire laptop. There might be an interconnect device, right? Like a switch or up, there might be a device I need to connect between Dell and Lenovo, so that only they can communicate or they can connect. So if we do that in that way, everyone will use on their own standards. So it is not a user friendly thing, right? So what this ISO, like International Organization for Standardization, so they researched all of these things, and like in the same way in the networks also. So they researched all of these things and they invented a model. Okay, so like everyone should follow this model whenever they are building something. Okay, whenever you are building a laptop or building a network, you should follow this stream. So this is your upstream, like, so this is the layer 1, physical is the layer 1, and application is the layer 7. Okay, so the stream should be from the bottom to top. So you will go, your traffic will go on this way. Okay, so op open system interconnection is the full form of the OSI model. Okay, and it is a standard procedure, like in each and every network. Like suppose you are using internet, and right now I am talking. Okay, how the packet is flowing, let me tell you. So first the packet will be go to my laptop, the NIC card I told you right yesterday. So the wireless card will be there, or your physical ethernet cable will be there. Okay, okay, so once it goes to the card, so that is the first step. Physical connectivity should be there, right? Like how you are communicating. Okay, so how you are communicating is the matters here. So first, whenever anything you do, it should enter into your card. NIC card or wireless or hub or repeater or your cable. So that is the physical one. First, you should have the connectivity. Like right now, we are connecting through the wireless network. We have a connectivity through wireless network. So that is also a physical connection because it is happening between multiple devices. Okay. So that is the physical part. So you have the physical connectivity. Okay. So the next one is data link layer. Okay. The first one is the physical layer, and you can see the hubs and repeaters. Yesterday we discussed it, right? Those devices will be operated in the physical layer. And the next one is the data link layer. So in the data link layer, um, so what it will do is like so first the switch we are discussed, right? The switch will operate it at data link layer, and so here in the physical layer, like in the layer one, we will call our data as this one. What is it? Bits. Okay, because the computer can only understand the binary language. The binary language is in bits. Okay, so like zeros and ones. And data link layer, what it will do is switch. So it switches the layer 2 device. So usually layer 1 is your physical or cable or something like that, and layer 2 switch is a layer 2 device, and so here your data will be called as a frame. Okay, so what it will do, like, so it will send the zeros and ones, right? This physical layer. So what frame will do, like if you are sending a data, so it will divide your data into a frame. Like, so we are sending hello, hi everybody. So we are sending this message. Okay. So usually this is how it looks when you send, but in a computer language it will send it in the bits. So what it will do is like it will divide that message into multiple frames. So in order to uh, in order to exchange the data as exactly it is, like suppose you are sending some data and if something is missing, maybe here the Y is missed, so there is no reliability, right? There is no reliability. Like there is no uh, 100% delivery of data. So there is something missing. So that's why what it will do is like simply if I say it will divide hello into one frame, hi into one frame, and everybody into one frame. And it will do like for frame one, it is one, and frame two, one address, frame three, one more address. So it will give a number for itself, and whenever it is transferring it to the next layer, so it will send those frames, and it will receive the confirmation like okay, frame 1 is delivered, and frame 2 is delivered, and frame 3 is delivered. Okay, there is a table, we will discuss it later. So like it will add a header and footer actually. Suppose in between, so we are dividing the data, right? We are dividing data into hello, hi, everybody. So what it will do is like in between hello, in between H and O. So it is hello, right? So in between H and O. So it is a header. H before adding the data is header, and after adding the data is footer. Okay. So what it will do is like it will add a header. Like for example, it will add a header, like I'm just telling in the normal language. Usually it will do in the ones and zeros. So I'm just telling, okay, it will add a bit called K here, and it added a bit here L. So once I transfer the data, how it will confirm in or confirm the data is transferred correctly or not is by verifying the header and footer. Okay. So whenever there is some data is transferring between two devices, so the data is divided into the frames. Okay, in data link layer, we will call our data as a frame. So your data is divided into frames, And if any errors in your data, any error detection, and the data needs to be delivered as exactly. So for that, it is responsible, like the layer 2 is responsible, and whenever like you want to transfer something, it will add a header and footer to make sure your complete data is delivering. And yeah, right? This is the data link layer, and it's a layer 2, and here the switch is we are using. So switch operates by using the MAC address. So it's a physical address. Okay, so don't worry about it. I will discuss more about this frames and everything. I'll explain you later. So, but this is the data link layer. So whenever your data is transferred, first you will go through your physical, and after that it will go to your switch. Okay, so right now we are in the data link layer, and our data is getting into the frames. So whatever I am talking, there might be an header and footer added before that information to deliver exactly how it is transmitted. Like I'm telling like hi everybody, so it will add a header and footer. Like before hi it will add a bit, and after everybody it will add a bit. So it will make sure we are delivering the same thing or not. Okay, and it will do the error detection also. Suppose if there is something wrong in the data, like I'm doing hello but it is transferring like just hi, so that there is an error, there is a mismatch. So in data link layer it will detect that, and it will discard that packet. Okay, that frame. Okay, we'll discuss about this. Just understand, data link layer is a layer 2, and switch will be operated at the data link layer, and here data will be called as a frames, and in frames our data will be formatted into a sequence to deliver uh, to for reliable connectivity. And you can remember one more thing, like yeah, in layer 2 we have the error detection. Okay, and the next one is the network layer. Okay, so right now physical layer, it's a cable, and in the data link we are using a switch, and it operates with the MAC address only. Okay, only with the MAC. In the network, so you want to connect between multiple networks, so that's how. So this is your one laptop example, and you have a IP as a 192.168.1.1. So my IP is 10.0.0.0.1. So these two are the different networks actually. So I'll let you know once we are explaining about the IP addresses. So these two are the different networks. So if I want to communicate between different networks, there should be a router, because router is a layer 3 device. So layer 1 is physical, layer 2 is data link, and layer 3 is network layer. So router is a layer 3 device. Okay. So if you want to communicate between different networks, just to like remember it. Okay, if we want to communicate between different networks, we should have a router. So the main functionality of the router is we need to communicate between different networks. Okay, so in layer 3 we will operate it like we will connect using the IP address. Okay, in layer 2 we will connect using the MAC address. In layer 1 we will using connect basic we will connect using the method of the connectivity, like whether it is a LAN cable or whether it is a Wi-Fi connection. Okay, so method of connectivity is physical, and in the data link layer, so it will operate in the MAC level. In the layer 3 it operates in the IP, like. And here, so your main device is router 3. It like router, it operates between multiple devices, like multiple networks. Okay, and your data will be called as the packets. Okay, so that's why I'm using a packet whenever we are doing something. because mostly we will do everything in the network layer only. Okay. And so here each and every device has a dedicated IP address, and what it will do here, like, so if I want to go to internet from my PC to I want to go to internet. So what it will do, it will analyze the path. Okay, it will analyze the path. So the path means how I want to go, like whether I can go with the ISP. I have two, LAN and WAN, and which one is the speed? Mostly LAN is the speed one. So it will decide which way I need to go, which is the faster way. And if I want to go to google.com, how should I go there? So everything will be defined by the router. So router is not a device, it automatically operates. We will do everything in the router to work like however we want. But it has a capability to do like a connectivity between the multiple networks. Okay. So everyone understood about these three layers, or any doubts? Before going to other layers, yeah, we'll discuss here and we'll sort it out. Apart from that frames part, if you are get confused in the frames part, just leave it, because anyway we are going to do some I'm going to show you like how the frame looks and what is the data going to be added, so you will understand it easily. So what is which device operates at the data link layer? Can anyone tell me?
Switch.
Okay. So what is the physical layer? What it will do?
Data is transferred into bits.
Okay. Data is transferring in the bits. Here it is the answer, right? Physical structure, the way of connectivity, how we are connecting to that.
It's method of we said like method of
Yeah,
connectivity.
method of the connectivity, like the physical or wireless, or whether you are connecting through a fiber, or whether you are connecting through a hub or repeater. So that tells the physical layer one. Okay, here your data is in the form of bits. Okay, in the binary format. Coming to the data link, our data will be in the frames, and so your Ethernet, so MAC address. So whenever you refer the Ethernet, so you have a Ethernet card, a NIC card, and that is associated with the MAC address. And switch is operating at the layer 2, okay, because it works based on the MAC address table. And which table will form by the switch? So yesterday we discussed it, right? Like switch is a switch whenever a device is
Second.
connected to. Sorry. So switch. So suppose you have connected these many devices. Okay. Here, if you see, I'm just writing in this bottom one. You have connected these many devices. So how switch will know? So I am Vinod. You are Ajay. You are Sneha, you are Bharat, you are Kiran. So how switch will know?
By
So
IP, by MAC address. Yeah.
yeah, so by MAC address, it will form a MAC information table. Okay, MAC information table, MIT table. So it will form a table, and whenever you connect it to a switch, first it will send a dummy packet to each and every one, like how we are saying hello when we join. So same way, whoever responds, I will grab their information, I'll store it in the my table. Okay, so that's how it will do that. And in the same way, in the network layer, if you go to the router also, it will form a IP table. Okay, here there are multiple names for it, like we will call it as a route table. So in the route tables, there are multiple things. Okay. So usually it will form a route table here, and our data will be called as the packets in the layer 3. So we will call it as a packets in layer 3, and so ICMP. ICMP means the ping, like how to do the ping. Like suppose if I want to see whether I am able to reach the Google or not, how we will test that? So usually, so if I want to see whether I'm able to reach Google or not from my machine, so I'll give ping google.com. Okay. So I'm getting a response. If you see reply from 2404, this is the IPv6 address. Okay. Usually we don't use that. But yeah, Google is updated, right? They are using it. So, so this is how we will receive, and these are the ICMP packets, like Internet Control Messaging Protocol. So by using this protocol, we will verify whether we have the connectivity or not. And IPsec, we have discussed about the VPN network, right? So it will tell you like what are the technologies, sorry, what kind of encryption methods we need to use, and all those everything we will discuss in the IPsec. Okay. Uh, and yeah, here your data will be called as a packets. Okay, remember that. And in layer 3, the device is router. So why we will use the router? Because to communicate between the multiple networks, the router, so to communicate between the multiple networks, we use a router. Okay. And the next one is the transport layer. Okay. So in the name itself, just you have the transport, right? So it is a take care of the transport of your data. Okay. um, so for example, let me tell you. So I have opened this. Okay. So so here you are seeing a padlock, right? If you go here, it is saying google.com. So, but before that, it will use a HTTPS. Okay, HTTPS. So, HTTPS is a protocol. Okay, so the transport layer operates with the protocols. Okay, so there are a lot of protocols we will use, for example, I'll tell you, you have a Wi-Fi connection, okay, in your home. You have Wi-Fi connection, and in your home, everyone will connect to the Wi-Fi, and you are using the Google, and they are using the Google. So, did you think like how it is working for both of you with the same IP? Because you have only one Wi-Fi connection, right? Yes or no? You have only one Wi-Fi connection, and everyone in your home using the Wi-Fi, and they are accessing the internet, and you are accessing the internet, and without any interruption, for everyone it is working. So how it is working? And with the single IP, usually one IP is for one person, right? So how it is working? So it's based on the ports it will work. Okay. So yesterday I showed you, like if I see, let's start. So whenever I am going to this, I am going with my IP over port 52374. Okay. So there are how many ports? A total 65,536 ports will be available in your in a system. Okay, like in this laptop, we have 65,536 ports. Okay, so 65,536 is the ports, and so with these many ports, whenever you connect multiple things, so if you see 52374 is for one Google, and if I establish one more, just let me cancel this. So 52377 for one more. So like that, you can have multiple connections and multiple things, but and each and every time it will go via a different port. Okay, you should have your IP and the transport layer, right? The way it is transporting using a ports. Okay, so here it will use the two ports. Either the protocols are TCP protocol or UDP protocol. Okay, we will call them as a protocols. So in that protocols we have the ports, whatever we are seeing here now. Okay, this 52374 or HTTPS, these are the ports. Okay, so basically we have two protocols. One is HTTPS, sorry, TCP, and another one is UDP. So TCP is transmission control protocol and UDP is user datagram protocol. Okay, so we will go into the next one like TCP ID UDP separately because we have a transport layer session. So in TCP and UDP, the main difference is in TCP, it will tells you whether your data is transferred to the destination or not. It will tell you whether your data is transferred to the destination or not. So if it is telling means, suppose if you send some data, like if I say hello, if I receive a hello back, that is an acknowledgement, right? And TCP is like that. Whenever you send some data, it will receive an acknowledgement. It will wait for the acknowledgement from other person. Okay. But UDP is not like that. Okay. It doesn't care whether your data is transferred to other end or not. So, but it sends your data. So okay, it's not responsible for data delivery, but TCP is responsible for your data delivery. Okay. Okay. So this is the transport layer. So basically, the way of your transport, like so the data transport happen. So here one more thing, the bottom four layers, if you observe, physical layer, it uses a cable. Data link layer, it uses a switch. Network layer, it uses a router. And transport layer, it uses ports. So these are all the physical, right? So that's why we will call them as a hardware layers. Okay, hardware layers. The bottom four will be called as a hardware layers or networking layers. We can call them as a networking layer also. All of them four. Okay, and the above three are the software layers. So the bottom four are the hardware layers, and above three are the software layers, because these three works at layer 7, like in the application means, so far whatever we discussed in the system level, the application means, so Google Chrome is an application now, and we want to see like how it works. So Google Chrome is an application, and so here the HTTPS or FTP or SSH, the protocols and everything, it will work in the application only. Like suppose if I want to connect to the Google, so I'll just type google.com. Okay, you see it is going to HTTPS. It is a secure connectivity actually. HTTPS means hypertext transmission protocol in a secure way. We have a HTTP that operates in the port 80. So okay, so these are the software layers. So these operates at application level. Okay, not in the hardware level. But our bottom four operates in the physical level, and just a minute. definitely we should have some physical connectivity for each and everyone there. So above three, there is no dependency with the hardware. But here, if you see the communication between bottom three and top three is our transport layer. So you need to understand like it is responsible for the communication between hardware and software layers also. And it will do the communication basically using the protocols. There are two protocols. So one is the TCP and another one is the UDP. So TCP is the more reliable one because it is responsible for data delivery and it will wait for the acknowledgement. And UDP is user datagram protocol. UDP means TCP is transmission control protocol. So UDP will say like I'm not responsible for data delivery. I'll just deliver it. It is like a Wi-Fi connection. So whether you will reach internet or not, it doesn't matter. But you have to send the data. Whether it is reached your destination or not, it doesn't matter. But it is like a TCP is like a postman. Like once you reach, if anything delivered, yeah, we will get an acknowledgement. In WhatsApp, we are seeing some blue ticks, right? That is an acknowledgement. Like if you see double ticks, that is it is delivered to the other person. But in some cases, I'm not remembering any application which is related to UDP. So in same way, so there will be some things will be there like whether it is not responsible whether your data is delivered or not. So you will just send a message and you will ignore it. Okay. And so coming to the session layer. Okay. So now you are connecting to the Google. Okay. So I have connected to the Google. And so the session layer, what it will do is like it is responsible, for example, it is responsible for establishing the session between me and the Google. Okay. So it is responsible for establishing the session between me and application, whatever the application. Okay. And session management, like how the data need to be transferred and uh, and suppose if you don't want you we will disconnect Google, right? So I'm just disconnecting. So after disconnecting, yeah, it should leave that session. So that's how. So we will we have session layer for handling the entire sessions. Okay, like from establishing and until unless you are until unless you are continuing in the session, it needs to maintain of the session like the data transfer and everything. Okay, and so suppose you are using the Google, but if I say you are not only the person, right? So you are not only the person using the Google, there are many persons. So it needs to establish a reliable connection between you and the Google. So it is responsible for that. Like there are some ways you will understand it by going forward, because if you explain it also it will become a clumsy. Uh, so it will keep a track. Like suppose right now we connected, right? So it will keep a track of our public IP. Okay. Then whenever we try again, definitely it will take to the same server. Okay. And the presentation layer is responsible for the data representation. And so we have the data in ASCII format, right? Like in the binary format. Okay. So there are some computers like who uses ASCII format, and another computers will use different languages. Like there are some in the binary also there are some different codes will be there. Suppose your computer is using ASCII, like you are sending the data in binary format, and other computer is not able to understand the ASCII language. Maybe it was using some different language. So the presentation layer, what it will do is like it will convert your ASCII format to whatever the understandable format by other computer. So for example, so we are talking English, we are talking in English, and someone is trying to talking in Hindi. So we don't understand the Hindi. So what it will do, like maybe someone knows about the Hindi in one of us. So what he will do, he will try to understand the Hindi language and he will try to convey us in the English. So same way the presentation layer also. So whatever the data you deliver, it will take it. And suppose if the other end it is not able to understand, so it will do the transfer to whatever the language it will understand. Then it will present the data. Okay. So and so the last one is application layer. So you know, right? We are using a web traffic HTTP. That is an application layer. It's a way of communicating with the application. And you have email. That is an application. It works under application. And yeah, there are many applications. You'll get to know. Yeah. Okay. Eventually. So. These about the layers, like total 7 layers are starting from physical to application layer. In the same way, um, suppose, so this is your laptop here. For example, this is your connectivity and you are trying to connect with my PC. So your user one and you have this layer one and layer two. So up to layer 7 we have. Okay, so same way here also layer 7 to layer 1. Okay, this is a user 2. So you are transferring your data, like first it will start from the physical layer, it will start from here and then it will go to the your layer 2 and layer 3, layer 4. So each and everything will do their functionality and it will forward the data to layer 7. Okay, then once it goes to the layer 7, where it should go? It should go to the destination, right? So your destination will be this one. So again you will receive the data in the layer 1 only. Okay, you will not receive directly in the application layer. You will receive the data to always to your physical address only. That's how it works. And the representation will happen in whatever the browser you use. Okay, and each and every device should follow this OSI model. Okay, without OSI model there is no communication and without protocols. You are seeing, right? So right now we have these many protocols with us. Even for your own communication also, it will use some protocols because you are using a single IP and you are tracking multiple, you are accessing multiple things. So it should differentiate, right? Between, so you are accessing Google and you are accessing Yahoo. How it should differentiate if you are using the same IP? It's based on the port number. Okay. So we will understand by Google and we will understand by Yahoo, but system will understand based on the port numbers only. Okay. So it will follow that. Okay. So yeah, I forgot to inform you like so in the TCP transport layer, our data will be called as segments actually. So in network layer it is a packets, right? In data link layer it is frames. So in the same way in the transport layer, it is called as a segments. Okay. So just walk me through any questions if you have. Um so that I can start another one. Like if you are okay with this. And yeah, you guys told like you will explain about the network devices or network topologies. So is anyone ready to explain? Definitely you should explain.
Guys, please ask the question. This is the basic understanding of this entire networking. If you have any doubts, please ask.
Vinod,
Yeah.
in data link, we'll send the data in bits form, right?
Yeah, frames in data link.
Frames, but the data sent in binary form, right? You said that header footer.
Yeah, yeah.
What is it? Header footer? I didn't got that point. Header and footer.
So header and footer means I need to draw that diagram, then packet diagram. Yep. I will let you know because anyway our next class is about that TCP/IP model, so we will explain that in that thing. Okay. I just
Okay.
don't want to confuse you on this.
Yeah, yeah, okay.
Okay. So can someone explain me about the hub functionality? Like how hub will work? Anyone? Or do you want me to call by your name and ask each and everyone? It's your wish. I can ask you guys, no problem. Bharat, can you explain about hub functionality? Uh,
Yeah. Uh, Hub or switch is same, right? Hub or switch.
uh-huh.
It is connect for the switch. More devices are connected. It's not like ring, so you can transfer data from PC to switch.
So hub operates at the physical layer and switch operates at data link layer. So definitely those two are different. Okay.
Okay.
And so these are layer one because if I say these are non-intelligent devices, it doesn't think about anything. But switch will think about something, right? That's why it will form a MAC information table.
Okay.
Yep. So whenever any device is connected to it, it will form a MAC information table. By using that table, it can identify the destination, like where traffic needs to be transferred. So we can say somewhat it is thinking right about how to transfer the data. So it's an intelligent device. Switch. Okay.
Okay.
Yeah. No problem. Thanks. At least you responded. So Ajay, can you explain about star topology?
Yeah, Vinod.
Yeah, please.
in star topology, we will connect some device which can connect to each and every connection uh, between the central device and the number of users are connecting.
Okay.
I mean, we can connect to multiple devices with using the single hub.
Okay. What is ring topology?
Topology. I think it connects only to two devices sometime. I mean, it's in a can connect through only circular. I mean, I think we cannot connect to in multiple way.
So what is the data carrier in ring topology? This is for Sneha.
So it's token form,
Okay.
and
So suppose if something break in that example, you have 100 systems and one
yeah,
system connectivity was break. So whether it will work or not?
if we have backup and it will work, sir. It doesn't work because it is in a ring form, so it doesn't work.
Okay. Okay. So what is the router main functionality?
Router,
Router main functionality. So why we use a router in our network?
um, it's to carry information in a secured form.
No.
Right.
So why we use a switch?
Actually, switch. Uh, it's in a logical form, and it has an MAC information table, so we'll use for an upper layers.
Okay. No problem.
Yeah,
Yeah.
thank you.
So I just pasted a link. So that OSI model explanation. So just please go through that and just explain me. Each and everyone needs to explain that 7 layers. Okay. What is the functionality of each and every layer? So after that, we'll go to the next topic like the TCP/IP model. Yeah. So from now onwards, I can start it, no problem. But the first thing is you need to understand it, right? So I will go to the topic, no issue for me. So tomorrow our topic is like internet protocol, IP address, whatever we are talking so far. Okay. So first we will see about the IP. Okay, but before that, you need to explain me about the OSI. That is mandatory for me. If you explain that, so I thought like you have some idea about the OSI. And tomorrow we will, if we complete, because IP is a big topic, if we complete IP, maybe I can explain you the TCP header and all this, like TCP IP model. So OSI is a logical model, like it's a like a it is like a practical, it is not a practical thing. It is like a plan. You have to use this, you have to follow this way, but the way we are following is TCP IP model. Okay, so we will discuss about that. Okay, but yeah, just go through that. Like, just explain me about the OSI. Okay, not all 7 layers. I'll give you each one one layer. Okay, that's fine. So okay, so here I'm seeing two Bharat. So Bharat 1902.
Sir?
I'm seeing two names here, Bharat Yalamarti and one more Bharat. So yeah. So Bharat, why? For you, you need to explain application, session, and presentation layer.
Okay.
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 And Bharat, one more Bharat. Yeah.
Yes, sir.
So you need to explain transport layer, session layer, and presentation layer. Okay.
Okay.
And Ajay, you need to explain about the physical data link and network layer. And
Yeah.
Chidambar, you need to explain about the network and transport layer in brief. And Sneha, you need to explain about network layer, data link layer, transport layer.
Okay, sir.
Okay. So just take one, understand it. Let me know if you don't understand it. We can have the same discussion because OSI is the basic model. And yeah, in your interview questions also they will ask you. So what is the functionality of the layer 7? Why we need layer 7? What is the use of it? And which applications are used in the layer 7? Or what is the transport layer? What is the functionality of it? What do you call your data in transport layer? We will call it as a segments. And what are the protocols we will use in the transport layer? So transmission control protocol and UDP protocol. So if you are going to be a firewall engineer, I'm telling you, you have to deal with the TCP UDP regularly. You need to understand how those two will work. So you will receive mostly a port open request. Okay. So the port open request means they'll give you some source IP, destination IP, and some destination port. You need to uh, like you need to verify whether the port is already open or not, and you need to open them. Okay, that's how it works. And so just go through the OSI model, and after that, tomorrow we will talk about the IP, okay, Internet Protocol, and then we will go to the TCP/IP model. Okay, otherwise I'll go to TCP/IP model first, and then we'll go to IP. Okay, that's tomorrow. Yeah, we'll see whatever is possible for us. We'll go that. And so if okay, no problem. You can come with this because from tomorrow onwards, I can give you some work also. Because as of now, we are going through everything theoretically. Just but go through about the devices. So you should know about the switch router mandatory and so the fire network types also. You need to understand about the network types, what types we are using. So just observe it. Like right now you are connected to internet, right? Just observe it. You have a Wi-Fi router and how you are connecting to your Wi-Fi router. So you are just connecting to a Wi-Fi SSID, maybe your SSID, but how it is like establishing the connection. Just try to explore yourself, you will get to know because these are the basic things we need to do. Like I know if you don't know the basic things, yeah, you will struggle a lot inside. So that thing even I can't teach you. It comes with your interest. Like you just need to explore yourself, like what is my system IP, how it is connecting to the internet, so how I am going there, so what are the basic commands. Just sit for 10 minutes, 15 minutes, you will get to know it. You have Google, right? You can type everything in the Google and you will get to know. Just do a research like that. and you will understand it easily. So how to see your physical address? What is the MAC address actually? What is my system MAC address? If I'm going out by using which IP I'm going out. So just explore those things. You'll get some basic idea. Okay. Uh, and yeah, that's it from my end. If you have any questions, please go ahead.
No, no loads. Once again, we'll go through that OSI model.
Yeah, please go through that. And yeah, once you go through that, maybe you'll get a lot of doubts and we can have something to discuss.
Yeah.
Yeah. So please go through that. And yeah. So anyway, from tomorrow we have something to do. Yeah. Okay. Okay then. Thanks everyone. I'm just closing a bit early today. Just go through that, and from tomorrow onwards, we'll go through IP protocols and how that IPs, classes, what all those, and we'll see all of them tomorrow. So I'm just going to skip some few theoretical things, because those are not mandatory. So I'm just going to explain you what all are needed. I can explain you, but maybe I will ask you to go through some theoretical things. So, if possible, just come with the TCP IP model also. Just research about the TCP IP model. There is no difference between OSI and the TCP IP. If you read it, yeah, it's just a similar thing. Right now we have 7 layers in OSI model, right? But in the TCP IP model, we'll have only 4. Okay. So the bottom layer, like the physical layer, network layer, transport layer, and application layer. The session and presentation layer will be clubbed to the application layer. Okay. So there is not much difference. Just go through the TCP IP model also, and you can explain to me, no issues. That's a simple thing. If you know OSI model, the same applications and same thing. Just it's a physical representation, like how we are using in real time. Just go through that and let me know if any questions. Okay.
Okay, Vinod.
Yeah. Uh, so okay. Thanks everybody. I will meet you tomorrow. Have a great day. Bye.